Hello everyone, welcome back to Snap's Let's Learn Academy. In previous lecture, we have discussed operating system design and implementation. In this lecture, we will discuss the operating system structure. As a system is a large and a complex as modern operating system, and it must be engineered carefully if it is to function properly and be modified easily. A common approach is to partition the task into small components rather than having one monolithic system. Each of these modules should be well-defined partitions of the system with carefully defined input, output, and functions. So already we have discussed this structure in the first chapter of the operating system, the common component of the operating system. Now in this lecture we will discuss how these components are interconnected and modeled into a kernel. So the example of the operating system structure is simple structure of operating system is MS-DOS. So MS-DOS is the example of operating system structure. So it is a simple structure. So many commercial systems do not have well-defined structures. Frequently such operating systems started as small, simple and limited system and then grew beyond their original scope. MS-DOS is an example of such system. It was originally designed and implemented by a few people who had no idea that it would become so popular, and it was written to provide the most of the functionalities in the least space. So it was not divided into modules carefully. As you can see this simple structure of the MS-DOS. So this is not divided into modules. It is implemented in least space and provided the most of the functionalities to the user. Now in this MS-DOS structure, this is the simple structure of the MS-DOS. Now here you can see there is an application program which is interacting directly with the BIOS device drivers. Means this is the hardware components. So directly application program can interact with the hardware, or they can interact with the system program, then device driver, then BIOS device drivers. So MS-DOS, the interfaces and levels of the functionalities are not well separated. You can see directly user can interact. So therefore we are saying that functionalities are not well separated. So application programs are able to access the basic IO routines to write directly to display and disk driver. So application program can directly write to the hardware or disk driver or directly to display. Such freedom leaves the MS-DOS vulnerable to malicious program, causing the entire system crash when the user program fails. Assume that the application program, that is the user program, if user program fails, the entire system crashes. So of course this MS-DOS was also limited by the hardware of its era because of the Intel 8088, for which it was written, provides no dual mode and no hardware protection. The designer of MS-DOS has no choice but leave the base hardware accessible. So the kernel provides the file system, CPU scheduling, memory management and other operating system functions through the system call, takes in sum, that is an enormous amount of functionalities to be combined into one level. that is the monolithical structure. And this monolithical structure was difficult to implement and maintain in this simple structure. So let us have the second structure, which is the monolithical structure. In this monolithic structure, this structure is the simplest structure for organizing an operating system and is no structure at all, that is the place all the functionalities of the kernel into a single static binary file that runs in a single address space. This approach is called as or known as monolithic structure. This is a common technique for designing an operating system. It means that all the functionalities of the kernel is written in a static binary file and run in a single address space, which is called monolithic structure. Now you can see this is the monolithical architecture where there is applications at the user mode handle other operating system features, and in kernel mode handles only the basic operating system functions such as file system management, process management, memory management, input output management, concurrency, and device management. And at the bottom layer you can find the hardware. So this is the monolithic architecture. So example of monolithic operating system are Windows, Linux, Mac OS. So having some of the disadvantages in this monolithic approach, because in monolithic structure all the functionalities are wrapped in the single file. So therefore the next layer approach is used. So the next solution for the operating system structure is the layered structure. The monolithic approach is often known as tightly coupled system because changes to one part of the system can have wide ranging effect on other parts. So therefore the alternative to this, we could design loosely coupled system. Such a system is divided into separate smaller components that have specific and limited functionalities. All these components together comprise the kernel. A system can be made a modular in many ways. One method is layered approach, in which the operating system is broken into number of layers. The main advantage of layered approach is simplicity of construction and debugging. Now you can see this figure. So this figure is a layered operating system. So the main advantage of the layered approach is simplicity of construction and debugging. So individual layers can be constructed and easily debugged wherever we find the error. The layers are selected so that each user functions and services of only lower level layers. This approach simplifies the debugging and the system verification easy. The first layer can be debugged without any concern for the rest of the system. So assuming that there is error in one of the layer, or we can say the first layer, without consulting with the other layer, we can debug the error in that layer itself. So this is the benefit of this layered approach. Once the first layer is debugged, it is correct functioning can be assumed while the second layer is debugged, and so on. If an error is found during the debugging of a particular layer, the error must be on that layer because the layer below it are already debugged. Thus, the design and implementation of system is simplified. So this is the major advantage of this layered approach. So this innermost layer is the hardware layer. You can see layer 1 is a hardware layer, and layer 2 is a CPU scheduling layer, layer 3 is a memory management layer, layer 4 is a process management, layer 5 is a input output buffer, and layer 6 is a user program layer. So all the layers are implemented, and all the functionalities of the layers are divided, so that we can easily find the errors, we can easily debug a particular layer, and error must be on that layer. The major difficulty with the layered approach involves appropriately defining the various layers, because a layer can use only the lower layers. Carefully planning is necessary. A final problem with this layer implementation is that they tend to be less efficient than other types. So, the example of layered based operating systems are Unix, the OS, VMS. The limitations have caused a small backslash against layering in a recent year. Fewer layers with more functionalities are being designed, providing most of the advantages of modularized code while avoiding the difficult problem of layer definition and interaction. So therefore, we have a microkernels. The microkernels has been developed in mid 1980s. The researchers at Carnegie Mellon University developed an operating system called Mac that modularized the kernel using the microkernel approach. This method structures the operating system by removing all non-essential components from the kernel and implementing them as a user-level program that resides in separate address space. The result is a smaller kernel. You can see. So the result is the smaller kernel. The main function of the microkernel is to provide the communication facility between the client program and various services that are also running in the user space. So this is the user space. This is the user space. So in the user space, most of the services are running and communication is provided by message passing. For example, let's say that if the client program wishes to access a file, it must interact with the file server. The client program and the server never interact directly. Rather, they communicate indirectly by exchanging message with the microkernel. You can see there are messages are passed to the kernel, and kernel can interact with the hardware. So any user wants to interact with the server, it must pass the message, and that user can interact with the file server and that communicate with the microkernel, and microkernel can communicate with the hardware. So therefore we are saying that the main function of the microkernel is to provide the communication between the client program and the various services that are also running in the user space. So one benefit of microkernel approach is ease of extending the operating system. All the new services are added to the user space. So in user space, We can add all the new services, whichever the service we want. When the kernel does have to be modified, the changes tend to favor because the kernel is smaller kernel. So we make very minimal changes in the microkernel. All the changes are taken place at the user space. The resulting the operating system is easier to port from one hardware design to another. So the microkernel also provides more security and reliability since most services are running at a user level rather than the kernel. So unfortunately, the microkernel have certain disadvantages also. Let's understand the example of microkernel operating systems are Minix, QNX, L4 microkernel, and GNU herd. So microkernel can suffer from performance decrease due to increase the system function overhead. Consider the history of Windows NT. The first release had layered microkernel organization. However, this version delivers a low performance compared with that of Windows 95. Windows NT 4.0 partially readdressed the performance problem by moving layers from user space to kernel space and interacting them more closely. By the time Windows XP was designed, its architecture was more monolithic than microkernel. So therefore, so the disadvantage what we had in the microkernel to come out from those disadvantages, we have modules operating system. So we can have the modules, we can develop the modules so that we can give more freedom to the kernel and the user. So perhaps the best current methodology for operating system design involves using object-oriented programming technique or loadable kernel modules to create a modular kernel. Here the kernel has a set of core component and dynamically link in additional service either during the boot time or during the run time. Such strategy uses dynamically loadable modules and is common in modern implementation of Unix, Solaris, Unix operating system, Linux operating system, Mac OS, etc. Now this is the structure what we are talking about. So modules. So the kernel is divided into the modules and all these modules are implemented around the core Solaris kernel. Such design allows the kernel to provide core services yet also allows the certain features to be implemented dynamically. Apart from this modules, we have a hybrid systems. In the hybrid system, very few operating system adapt a single strictly defined structure. Instead, they combine different structures resulting in hybrid system that addresses the performance, security and usability issues. There are three hybrid systems we have: the Apple Mac OS operating system and the two prominent mobile operating systems. One is iOS, another one is Android. So these are the three hybrid systems what we have. So this is the hybrid architecture. So you can find there is a user mode. In the user mode, It handles the other operating system features like process management, file server, IO management and memory management, whereas the kernel mode handles only the basic features of operating system like device driver, low level address space management, low level process management, inter process communication, etc. So these are the basic operating system features which are handled by the kernel mode. Rest of the operating system features are handled by the user mode. So this is all from this lecture. Hope you understood all these system structures. So thank you for watching.